Hello everyone, how are you all? Welcome back to the class. I hope you all are doing really great, guys, and re-revising the concepts which we have already seen. So, as we had started in the last class, as we had started unit number 6, that was basically soil and water conservation, right? Under this, we studied in the last class what soil erosion and soil conservation. Now, in this particular class, we are starting this very important topic under this unit only, that is soil and water conservation, dry land agriculture and its problem, guys. As it is written in the syllabus, and it is a very important because every alternate year, this questions are being asked from this particular topic. So, before going ahead, as usual, our practice is to just see what all we have seen till now. So, under this unit, in the last class, just we will do the recap, and we studied about soil erosion and soil conservation. Now these two topics are written as it is in our syllabus, right? We had seen the previous year question too. I hope you have like tried to solve it. So, so under soil erosion, we a quick recap. Soil erosion, we saw that soil erosion is of two types, right? One is a natural, which is happening. Second one is accelerated. Now this accelerated is happening basically because of the agents, and natural is also happening because of some agents, and two major agents which we have seen is wind and water. Wind erosion and water erosion. Under water erosion, we studied about how water erosion is doing erosion in the form of splash, sheet, rill, gully, and further it is converting into ravines. We understood it. Every detail about it we have understood. I hope you have revised it also, and just pause the video and try to recall what all we have studied, right? In the same manner which we are studying right now. Wind, you have to remember that wind erosion happens by saltation, soil creeping, and suspension. I'm not telling you the details. Details you will know automatically when you will see this. Just try to remember the major headings under which we have studied things. Then, after studying this, we understood the factors that are affecting them. Factors affecting soil erosions, right? Under factors, we have studied what? 5 points. One was about climate. Under climate, you will write because what we have seen. Second was about topography, slope and degree, what we have seen in the last class. Third is about vegetation. Now you will expand it automatically if you will remember these points in the exam, right? That factors affecting soil erosion, and if you will remember these 4 or 5 points. Fourth was soil properties, and fifth was man and animal, or you can say human impact. Now these 5 points, these five subheadings, if you'll remember in the exam, automatically you will be able to write under it that how climate is affecting soil erosion, how topography is affecting soil erosion, how vegetation is affecting soil erosion, soil properties is affecting, and fifth point also. But you have to recall this in the exam, right? So keep this thing in your tips, guys. Then after studying the soil erosion, we try to understood the soil conservation methods, that how we can conserve the soil. And soil conservation, basically SC, we studied it in four different processes, like how we can conserve the soil. First one was agronomical method. Like this, you can show the flow chart. I have told you earlier in this class, in the class only, right? Second one was mechanical methods. Third one was agroforestry methods. I hope you have also recorded by pausing the video, right? Fourth one was agrostological, not agrological, guys. Agrostological measures. Now, what all about it we have discussed in the last class. I'm just re-revising these concepts. That in agronomical, you have studied about the choice of crops we should choose, land preparation, crop rotation, strip cropping, Contour cultivation, guys, not contour bunding. Contour bunding will come under mechanical. I have told you the difference. Then mulching, soil cover, like this. You just try to see that how many points we have just recollected right now. And in the examination time, if you are spending this much time now over here in the preparation phase, in the examination time when you will be writing, means automatically you will be utilizing this content in 7 to 8 minutes, and it will fetch you marks, guys. So this hard work you are doing right now to re-revise, it will automatically fetch you over there. So mechanical methods under this: contour bunding, graded bunding. In detail, we had all seen in the last class. No need to go through the details right now. Just try to see you can recall the sub points or not. Graded bunding, then terrace benching, then gully bunding or gully control, like this vegetative barriers, mechanical, which we are creating. These are engineering methods, right? We are creating something. In agroforestry, we'll grow the forest. In agroecological, we'll grow the grasses plus legumes. You know the details about. So this all we tried to see in the last class, and now we will move ahead and see the most important topic of this particular unit, that is dryland agriculture and its problems. Now, before going ahead again, as usual, our approach is first to see what they are asking. PYQs. Now, in PYQs, you will analyze that direct statements are being asked. Problems of dryland agriculture. They have asked dryland agriculture and its problems. Direct problems are being asked, that what are the problems, and describe soil constraints. That means one of the constraints they asked in detail. Differentiate between dryland farming, irrigated farming. So what you are understanding is through the PYQs that they are asking straightforwardly the syllabus part only. So what we have to do is, as usual, we have to fix the syllabus part. That means we have to have as much content for the syllabus, like the most we need for this particular content only. We don't have to go sideways. I mean, you don't go for the things which are not written in the syllabus. First, see the questions that are being directly from syllabus itself. Right, guys? So now try to understand. You just pause the video and see all the PYQs. We will just move ahead and understand a dry land agriculture. All right, guys. Dry land agriculture. What do you mean by this dry land agriculture? Or what do you mean by dry land? Automatically, one assumption would come to your mind that dry land must be that area where rainfall must be less, right? Rainfall must be less over there. That's why I'm saying that area is dry land. But you will amaze to know that dry land agriculture is not related to that only. It is partial truth. Dryland agriculture, fixed definition I'm telling you. Dryland agriculture is the agriculture where cultivation of crop is completely dependent upon rainfall. Cultivation of crops directly dependent upon or solely completely dependent upon rainfall. So I have, for example, I have this 1 hectare of land. As usual, I take an example. I have this 1 hectare of land. I want to grow crops in here. So there is automatically water requirement for the crops to grow. So water requirement for the crops is being fulfilled by two ways. Either from rainfall directly, or I can give it through rivers, canals, right? These are artificial methods. And this artificial methods of supplying water to the field is known as irrigation only. So one method of supplying water to the field is irrigation. Second method of supplying water to the field is rainfall directly, natural way. So if I have this land and I am depending upon rainfall also, and I am depending upon irrigation also. For example, I have a tube well over here and I am depending upon the tube well also. So will I call this particular land under dry land agriculture? No, guys. As you go for the definition, that cultivation or dryland agriculture is that kind of agriculture where cultivation of crops is completely dependent upon rainfall. If I'm supplying any water by any artificial means, that means it is no more a dry land agriculture. It will irrigated land or irrigated agriculture will say it. Now, dry land agriculture in broad terms is also called rain-fed agriculture. Why we will see it? Rain-fed agriculture. Don't get confused right now. Rain-fed agriculture is also being called dry land agriculture because it is directly depending upon the rainfall. Right. So right now, just understand this. And one thing which you need to understand now is the rainfall pattern of India, which you usually understand it in geography, right? Geography, you understand this in physical geography, class 11th, uh, under climate chapter. But here I am just recalling for those who have not studied it. I'm just recalling the rainfall pattern of India, that how much rainfall is distributed in what areas. So you will see that less than 500 mm area is this. That means less than 500 mm. That means 50 centimeter less than this rainfall is received by this area, and this area we call as arid region. Just try to understand this. You don't have to rectify. What you had to understand was the definition only till now. This you just have to understand that okay, what are all the regions. So these regions are basically Rajasthan, upper region of Gujarat, and a lower region of Punjab and Haryana. Now greater than 500 to 1000 centimeter, this means 50 centimeter to 100 centimeter of rainfall is between these areas. Less rainfall, right? Very less rainfall than less rainfall, and a moderate range rainfall is between 100 to 200 centimeter, or you can convert it to mm only, or you can keep it in mm only. It's up to you. But you see these regions as moderate type rainfall. Heavy rainfall areas are this region, Meghalaya, Cherrapunji. You also know that monsoon comes from here, and because of this topography, because of this, what do we call this kind of rainfall? Orographic rainfall happens over here because of this Western Ghats. If you have not studied geography yet, then you will be like understanding it later on. But I would say that just study today only. But when you will be studying it, you will be getting what is orographic rainfall and all. This is not the part of agriculture, but I'm just trying to link everything what you have studied. So see these areas, just focus on these areas. These areas are receiving heavy rainfall, right? Heavy rainfall areas are also coming under dry land agriculture. I show you how. Wait for now. All right, this much you have understood that these are the regions like Meghalaya, Assam, Tripura, Mizoram, Vagara, Vagara. They are coming under this heavy rainfall areas that is greater than 400 centimeter. All right, guys, this was the rainfall distribution you have understood till now. Now we will go ahead and we will see dryland agriculture only. Under dryland agriculture, there are three types which are being divided. It is being divided into three categories. Now, these three categories are being divided on the basis of rainfall it receives. These three areas. The areas which receives less than 750 mm of rainfall, that means 75 centimeter of rainfall. But you remember this 750 mm. The areas which receive less than 750 mm of rainfall is called dry farming areas. Dry farming, or you can easily say dry farming. And where crop cultivation is happening between, you have to rectify this, 750 mm to 1150 mm, we call those areas as dry land farming areas. Now don't go between these words, dry land, that why we are keeping these. You just have to understand it in this way only, because these are academic terms which you need to rectify. What is the difference? You will automatically tell the difference that dryland agriculture, this dryland farming and dry farming are differentiated on the basis of rainfall they receive. And that is basically 750 mm, and 750 mm greater than 750 mm, less than 1150 mm is dryland farming. I hope you are understanding this much. Now the areas which receive greater than 1150 mm of rainfall, greater than 1150 of rainfall is known as rain-fed farming. So these three categories you can see. Again, I am recalling you, dryland agriculture is the agriculture where the cultivation of crops is completely dependent on rainfall. That means there is no source of irrigation and no irrigated water is provided to that field or to that area. Under dryland agriculture, we are dividing these into three categories. The rain where we receive less than 750 mm is a dry farming. Between 750 1150 dryland farming, and greater than 1150 is rain-fed farming. Now the notion in the starting, what I have asked you, that you must have assumed that dryland is the area where we receive less rainfall. Now, are we receiving less rainfall in this region where greater than 115 centimeter? Moderate and above moderate rainfall I am receiving, but still it is coming under dryland. You see the difference, guys. I hope you have understood what my point was. Now, second category. Now you see the areas which are located under this dry farming. Under dry farming, what areas will come? Now the what I have shown you rainfall pattern of India. Now you will automatically know that the region which will come under dry farming are the arid regions, and we have arid regions basically in western Rajasthan. Western Rajasthan. You need to have good geography for this. Western Rajasthan, upper Gujarat or northern Gujarat, and some parts of Haryana also. But majority portion under dry farming is basically Rajasthan area, arid region. Under this 750 to 1150, you will automatically semi-arid. These are basically western UP part you have seen, or eastern Rajasthan, Bundi area, eastern Rajasthan. Don't worry about this. This is as it is written in the PPT. I'll just show you. All right. Then rain-fed farming is the areas of humid and subhumid humid regions, right? So these are the, like, certain, you can say, features of this particular farming you have to differentiate. Now we'll go to their typical features, like what is happening, what is the problem over here. You will see in dry farming there is a high chance of crop failure because rainfall is less. So there might be a season where rain doesn't happen or it is less than what is required. Crop failure chances are really high. So here we grow crops which are of less that duration, that can be grown in less time, and we call them growing season is less. So less than 75 days of growing season if we have of certain crops, we will grow over here because we are not having that much of rainfall, right? So that we can grow crop. We know that this much amount of rainfall will come, less than 750 of rainfall will come, and we can only grow crops of short duration, or you can say which has short growing season. So crop less than 75 days will be grown over here. What do you have to remember? 75 days. Obviously, when there is no rainfall and I have to grow one, I can only grow one type of crop. So what type of cropping system I am following over here? Monocropping. I'll write here. Monocropping. Now, if you have studied agronomy, which I have taught you already, you have seen that cropping system of monocropping is leading to soil infertility, or soil fertility will decrease over the period of time. Nutrient deficiency will happen in it. I have explained you this monocropping in detail. Don't worry about it. If you have not studied agronomy, just wait for the lecture, and if you have seen it, you would have understood monocropping in detail. Now you will go other problems we will study further because we had dryland agriculture and its problems as the particular topic only. So its problems, what are the problems of dryland agriculture? We will study it separately right now. Just wait. Semi-arid region. Now in this region, crop failure is not that much because we are receiving rain, right? Moderately rain we are receiving over here. Here we can go for the crops which has growing season more than 75 days to 120 days. Over here, which crops can be grown, like which has growing season less than, like millets, we can go for. under this pearl millet, finger millet, right? We can go for those crops. Here double cropping happens. Also, this monocropping plus a mixed cropping also happens over here. Now, the difference, clear difference between mixed cropping, mixed agriculture, monocropping, I have told you this in agronomy session, and I hope you must have like you are clear about this. Double cropping, right? Here we are use double cropping happens over here. Crop rotation also we can do. In a rain-fed farming, there is no like very less chance of this crop failure. So crop failure is next to negligible. But here you are seeing that maximum rainfall we are receiving over here. The problem here is not this. The problem here is of water erosion, runoff basically. Poor poor penetration of water, or you can say percolation is happening in greater amount. No water is stored over there, stored in the soil. Because of that, the problem is arising of water erosion and runoff. So it is creating problem because we cannot have like required moisture in the soil. The right word for these is a water holding capacity is poor. I hope this much is understood. Basic difference between this dry farming, dryland farming, and rain-fed farming. This much difference should be clear to you guys. Now we will move ahead and see other aspects. Now you understand this. See, I have shown you as it is in the PPT. Also, just pause the video. Just note every like the points I have told you right now. But we will move ahead and now some facts time. You have to note some facts. Now you have understood dryland agriculture, the types of dryland agriculture. Now you know that in India, we are dependent on monsoon, and monsoon is erratic in nature, irregular, you would say. Sometimes we are receiving more rainfall, sometimes less rainfall. So this type of system we have in India. Also, some facts like how much area is under dryland agriculture. Now, this point must come to your mind, and this comes under fact based, that what are the facts we need to have from this topic. I could also teach you like point wise that this area is under dryland and this area is under like rain fed conditions. But this would have been chaotic, and you have to remember a lot of data facts, not only in this particular topic but overall in optional, overall in GS subjects too. How much you will remember? So there should be a connection, guys. Now what I am trying to connect is you understand that you have seen the rainfall pattern. Now you have seen that most of the area in India comes under dryland agriculture only. Now you can imagine, see by this only you can imagine that how much percentage area can come under this. Wait, just wait. You see, this much area is also under dryland. This much area is also under dryland. This area is also under dryland because here irrigation facilities is not there. Rainfall we are receiving in large quantity, but irrigation facilities is not there. So obviously it will come under dryland. So automatically you try to guess what will be the percentage of uh, land that is cultivated in India is under dryland agriculture. Dryland agriculture. I write it in short. So dryland agriculture, under this we have greater than 60 percentage area which comes under dryland agriculture. Remember this point as it is. Now when the large like land part is under this dryland agriculture, automatically there would be certain population which will be dependent upon it. 40% of the human population is dependent, our population is dependent upon this dryland agriculture. Now importance of dryland agriculture is increasing. We have to see the constants, we have to protect it. Why? What are the problems of it? That's why it becomes important for us to study, and that's why it is in your syllabus. Now 60%, more than 60%, usually somewhere you will see 66%, somewhere 63%. You just write greater than 60% area is under dryland agriculture, where 40% of the population is dependent. Remember this point also. Also the importance grows when you will see that 42% of food crops. Guys, this I am writing this 42%. I want you to remember it forever. Like This should be fixed, rectified by you. 42% of the food crops. And if you have seen my agronomy lectures, I have told you that under food crops comes cereals, under food crop comes pulses, right? So 42% of the food crops is like dependent, or we are getting 42% of food crops from DLA, dry land agriculture. You will be amazed to know that 72% of oil seeds we are getting from dry land agriculture. Again, you will be amazed to know that 90% of pulses we are getting from dry land agriculture. These three things you should, you should know, because when you will be writing in the intro the importance of dry land agriculture, these facts should come straightforwardly. This much is the minimum. More you can add by current affairs if you are reading some article on dry land agriculture. From there you can also recollect. Now there will be no limit of all this, right? But we have to have some fixed data with us. This I am telling you guys for the intro. For the conclusion, if you want to write that what is the importance of dry land agriculture, there you will write this. This much data is important and you will write it. All right guys, let's move ahead. Now let us see the basically constraints part or the problems part, which is very important. Constraints or problems in dry land agriculture. First main heading which you will see is of climatic constraints we have in this particular areas. Climatic constraints in dryland agriculture areas. Dryland agriculture areas are those areas where rainfall, where the cultivation of crop is solely dependent upon rainfall only. Here we are dividing into three parts based on the amount of rainfall we are receiving. Are you understanding? And you also know that if less than 750 mm of areas we have, and greater than 1150 mm of rainfall areas we also have here. So under climatic constraints basically comes 2 points: a rainfall category and temperature category, right? These two basically are the major factors or major constants. How we can see rainfall? You know that rainfall is like its intensity and distribution is erratic or irregular. Distribution, if you will see in space thing or space time, that means time and space. If you'll try to know, space means in some areas we are receiving heavy rainfall, in some areas I am receiving scanty rainfall. If you will differentiate the rainfall like in the basis of this time, then you can say that for short time I am receiving heavy rainfall, for short duration only I am getting, for long duration I am getting the rainfall. Like this you can differentiate, right? Now you see the problems in the areas of heavy rainfall. Now what are the areas that come under heavy rainfall areas in dryland agriculture? Automatically you will see that those three categories, and this 1150 greater than those areas are come under this heavy rainfall areas. Now here the problem is of flooding, runoff, soil erosion because of water erosion a lot. So here the problems are this. When you know these problems, then you can identify that how we can conserve it. So when they will ask you for the solution of dryland agriculture, then you directly hit at this point. Likewise, you give solution that in the areas of heavy rainfall where flooding and runoff are like seen most of the times, can be like conserved by these methods which we'll be studying, like by making water harvesting system, percolation tanks. We will be seeing that. Don't worry about it. Just try to see the differences right now, constants right now, right? Heavy rainfall areas of flooding and runoff is the major problem. In scanty rainfall areas, what is happening? Droughts. Frequent droughts are happening. Automatically scanty rainfall areas less than 750 mm. You have to be specific, guys. Those areas of western Rajasthan, arid regions basically. Here you will write those regions. So rainfall is getting distributed in space, is different in space and time. You can see the intensity and duration difference between space and time. In space, we are seeing that there are areas where we are receiving heavy rainfall, areas where we are receiving scanty rainfall. Time for short duration, like in monsoon time, in 2 3 days I receive most of the rainfall, like 50% of the rainfall. So it is bad for my crop growing, right? Because in my crop growing season I need water requirement at every part, like in the germination part, in the vegetative phase, in the flowering stage, in the termination phase, at every stage I need requirement of water. But in the first few days only, sometimes water we get 50% of the water. That is the problem, that for short duration we get it, and sometimes we get it for long duration, like we are getting water requirements when we don't want it. So this particular constant is because of rainfall. Now you see temperature problem is because of high temperature in arid and semi-arid regions. What is happening? ET losses are happening. What is ET? Evapotranspiration losses. Evaporation plus transpiration is happening large amount. So moisture which we need is basically is lost in this form, evaporation and transpiration form. Now don't try to understand right now if you don't know evaporation transpiration. We will study this in part 2 physiology. Don't worry about it. You just understand that evaporation, you all know. Transpiration also, it is a method of like uh, water get lost in the form of water vapor through the plant leaves. So we will understand it in detail. It is a part of syllabus, don't worry about it. But just now you understand that because of temperature we are losing our this moisture in the form of ET losses. Already we have low rainfall, already moisture is less, already we are receiving less water in the form of rainfall, and also we are seeing this high ET losses because of temperature constants, high temperature areas, basically in arid and semi-arid areas of Rajasthan, you can see. First one is this constant. Now second constant you talk about. Now also rainfall and temperature you talked about. Climatic constant is also that India received India receives its rainfall from monsoon. You all know that. Now monsoon has a problem, as I've told you, the erratic in nature, irregular in nature. So under monsoon also three conditions happens. Now see this. We were studying climatic constant. This will be your heading, guys. Climatic constant. Under climatic constant, you studied rainfall, and on the basis of temperature, what are the constant? Under rainfall, you have told that the intensity and distribution in space and time is different. In space time you will know about the high intensity or high rainfall areas, or here scanty rainfall areas. Time you will say long duration and short duration. In temperature, high temperature areas, arid and semi arid areas, ET losses. Third part which is coming under climatic constant is a monsoon, erratic monsoon. What is happening? Sometimes this monsoon is coming late arrival of monsoon. Sometimes this monsoon is coming or is going early withdrawal, we say it, early withdrawal of monsoon. And sometimes what is happening is in between there is monsoon breaks, like you have understood it in physical geography, that there is breaks in the monsoon, in the rainfall which we are receiving. You can say breaks in the rain I am receiving from monsoon. That first few days it happens, then it took a week for rain to happen again. This is called a monsoon break which is happening. So these three things, these three conditions are also affecting my crop growth, crop season. So that's why it is not feasible. What they are doing is basically my yield is being decreasing. If my yield is decreasing, I am like going economically down. Automatically, the pressure will be on a farmer. He or she will be poor because of this economical or because of this poor yield. They will not be getting the profit they have planned for. Again, I'll try to connect it later on also, that these farmers again they are get remaining poor, and they cannot afford good education, good health. They cannot afford good inputs for the agriculture. So again they will grow the same crops in the same manner without using some good fertilizers, good pesticides. And again their yield will not be good because of these climatic constant, or these because they are growing in a dry land agriculture areas. You can connect all of this, but till now you just see the major heading, that is climatic constant. What you all have to write if this factors point come, then what are the problems under climatic constant, you have to write this much information. Second point which you can highlight, important point which you can highlight in uh, dryland agriculture areas, the problem is basically of soil properties. Anywhere if you are saying that this particular area is a dryland agriculture area, automatically one thing will come to your mind, okay, here are climatic constant of rainfall and like temperature. Second one is, okay, the soil here has some constant also. Soil properties means, or the soil problems, basically you can say soil constraints is that here soil has less moisture. A, because of scanty rainfall. In the rainfall in the areas which where we are receiving less than like where we are receiving less rainfall, or in the areas where we are receiving maximum rainfall, there is less water holding capacity of the soil. So basically, if the soil is not able to hold the water it is receiving, it is we are losing it in the form of a runoff, and this runoff is causing a water erosion. This we have studied in the last class, how water erosion happens in the form of splash, sheet, rail, gully, and many more. We have also seen the factors which are affecting them, right, in the last lecture only. Now, because of this, what is happening? Poor condition of soil is becoming, right. Less moisture is there. Now, because of less moisture, less vegetation will be there. Try to connect. Now, this less vegetation areas are arid and semi-arid areas. If less vegetation is there, then automatically organic matter will be less. Now, this how organic matter helps. This all you have studied this in unit number 5. That is when we were studying soil properties and soil and basically soil and nutrient management. Under this unit, you must have studied. I have told you this organic matter concept. Now, if organic matter is less, then automatically the physical characteristic or physical properties of soil. Now, in this unit only, we had studied physical properties like texture. I hope you are remembering the topics and re-revising it. Texture, structure will be poor. Now, because of that, the fertility of the soil will be less. Fertility, less organic matter. Second point, fertility of soil is less. So the areas which you will call, okay, this area is under dryland agriculture, you can assume that, okay, this area might have less fertility because here organic matter content will be less. Here the soil water holding capacity will be less. So fertility of the soil is less. Now, because of this less fertility of soil, automatically you can say that here the yield will be poor. If yield will be poor, then the socio-economic condition of farmers will also be poor, as I have connected just before also. You can also, one thing comes also come to your mind, that we can increase the fertility of soil by applying fertilizers, right? Here we can apply fertilizer and we can increase the soil fertility. But here it also doesn't happen because fertilizers are being taken by the plant in the form of some soluble form, like in the through the form of water only, right? But because of this less availability of moisture in these particular areas, the fertilizers also doesn't get utilized as they have, as they want like irrigation. That's why fertilizer need irrigation na. That's why they are more responsive to irrigation. Where irrigation supply is there, their fertilizer will be responsible, but these areas are not responsive to fertilizers because of less moisture they have. So low input efficiency, you can say. Whatever we are using, for example, if we are using fertilizers, these fertilizers are not responsive because of less moisture we have. So these are all constants under soil which you have to see also, which you have to understand is, again, wait, just let me draw the map. Sorry for the map, guys, but you just try to understand. You have seen the, if I'll ask you for the arid regions, okay, this much area is also under dryland. If I'm not receiving any artificial means of water supply, this area under, you can say, dryland, this area under dryland. Now, when I have taught you this and I've given you the homework that soils of India is the homework for you, you have to do soils of India. You must have seen that this area particularly, or these areas particularly, this area is under black soil. plus red soil. Now these two soils have their constants also. Red soil basically we call them alphy soil, alphy soil, and black soil we call it vertisol. They have their constant also. Red soil goes for crusting. Crusting problem happens in the red soil when after rainfall dryness or after rainfall dryness happens. Because of the dryness, the soil is converted into a flat like this crust type structure. Basically, it what it is doing, if there is seed, then the seed will not germinate because it will obstruct this hard pan like structure will obstruct that seed to germinate. Also, this will reduce the water consuming or the water percolation capacity also. So this water will be moving in the form of runoff because it is not being absorbed by the soil. In black soil, what we see that cracks develops, right? Pan or crust like here also you see the crust like structure happens after the dryness period, after the when the like a dry spell comes. So these soil problems are over here also. You can also write this over here, this data. See, in climatic constant, you have seen rainfall characteristic. I have pointed it out. What I have told you right now, you can see this in the PPT. Climatic constant, we have studied soil constants. Again, poor soil fertility, we have seen. Soil crust problems in red soil, that is alphy soil, and verti soil is basically black soil. Also, black soil also happens this crusting problem. Poor organic matter content, I have told you. So these two basically are the major constants which we have, constants of DLA. One, we have studied climatic. Second, about soil constants. Third, are like generic in nature. For example, traditional practices still goes on, like monocropping. Now, obviously, though don't have a means to like grow like crops which are like can be grown in a year because they are receiving less than the 750 mm of rainfall. How will they grow few like more than one crop? There are some constants, right? So traditional practices like monocropping is still going on because of this soil fertility. Again, it is impacting on the soil fertility. So the farmer is or the this dryland agriculture is basically revolving in a vicious cycle. Farmer is bound to go for this monocropping. This monocropping will lead to soil infertility. This soil infertility will lead to less yield. This yes less yield will give me less profit. Again, the socio-economic condition of the farmer will be like poor only. It will again the farmer will not be able to go for what inputs, you can say education, health. So this is a vicious cycle which is going on. You have to turn this cycle into a virtuous cycle. How we will see it ahead. Fourth is here weed problem is also there. Now weed problem is everywhere where crops are being grown. Weed problem comes over there. But the farmers who can afford like labor or herbicide, pesticide, they can kill it easily. But here labor problem is also there. Input problem is also here in dryland agriculture areas. So weed problem is one of the major constants also. Other, you can say the socio-economic condition of farmer is poor. These are very generic in nature, guys. You can write as many points like this. Let me show you. Just wait. See, climatic constants we have seen. Uh, this climatic constant we have seen. Traditional cultivation. One important point is lack of suitable varieties. You try to understand this point. We are introducing hybrid varieties, guys. Now these hybrid varieties need irrigation, need fertilizers, high input of that means they are needing high input. Whereas dryland agriculture, how you are going to provide irrigation where water we are receiving from rainfall, and that too very scanty. One problem is this, that these hybrid varieties will not be able to grow in these dryland agriculture areas because automatically you need irrigation for that. But I am not getting that much water in these areas. So I have to grow, I have to invent, I have to innovate certain type of localized varieties that will only be beneficial for these dryland agriculture areas. So invention and innovation is needed for these dryland agriculture areas so that those crops could be grown which are drought tolerant, right? So this what is meant by lack of suitable varieties. Soil related constants you have seen, heavy weed problems, socio-economic constants you have seen because of this, how it can go to the what which vicious cycle that will happen. Now it is up to you guys that how innovatively you can create the cycle also. This is up to you. I can only tell you certain things. Now rest is up to you to innovate this kind of information. This information I'm giving you, you can innovate as per your capabilities, guys. All right. So we'll move ahead now. Let us just see what all we have seen till now, and this should be on your tips. What all we have seen till now, this should be on your tips, guys. Right now we started the class with trial and agriculture. You know that the areas where we are completely depend on rain. I told you that trial and agriculture is important because of certain factors. More than 60% area of cultivated land is under trial and agriculture. You know that 40% of population is dependent on it. You know that 42% food crops I am getting from here. 72% of oil seeds I am getting from here. Oil seed production is happening from these areas. 90% of pulses are being grown from over these areas. This much fact you should know. Dryland agriculture area is academically, or you can say it is being divided into three categories. The areas where I am receiving less than 750 of rainfall, I call them dry farming areas. Basically, these are areas, arid regions, we call them arid regions, right? You can give the example of Western Rajasthan. You know that here 75 days or less than 75 days of crops which growing season is less than 75 days, those crops are required. Here crop failure chances are very high. Here monocropping and mixed cropping is practiced. Then I am getting like on the basis of rainfall which I am receiving, if I am receiving it between 750 to 1150 then I call it dry land farming. Don't get confused, guys. Dry land agriculture, dry land farming, it is a part, it is a category under this dry land agriculture, right? You can easily differentiate in on the basis of rainfall we are receiving. If I am receiving greater than 1150 we call it rain fed farming. After that we understood the rainfall pattern on all we have seen. Then the important topic was the constants which we have to see, that what are the constants basically. Constants you have seen, major constants, climatic constants, which you will explain in the form of rainfall and temperature and monsoon. Under rainfall, you will explain them on the basis of time and space, how it is being, the intensity and distribution is irregular. Space may you will show them high rainfall areas, low rainfall areas. Time may you will say short duration, high or a long duration. In the temperature, you will say high temperature areas, ET losses. Monsoon, three conditions: late arrival is happening, early withdrawal is happening, and breaks are gaps are in between this monsoon I'm getting. Then soil constraints. Automatically soil constant, when it will come to your mind, what should come to your mind, that soil, over here the soil problem is moisture content is less because of this low fertilizer input or low input. You can directly write here red soil and black soil are present, and because of that crusting is the major problem over here also. And one or two points which I have told you. Other constants which are traditional cultivation, traditional practices, localized. You can say that the varieties which we are growing are not suitable for it, for these areas. Like the hybrid varieties are not suitable for these areas. You can also write about the weed problems, socio-economic problems of farmers, and you can also draw the vicious cycle and how you can turn into a virtuous cycle. We will see it. Till this much should be in your tips, guys. Till now, what we have studied. Now we will see the solutions related to it, or how we can these problems, if we are saying how we can, what are the solutions we can go for these dry land agriculture areas, right? Dry land agriculture areas. You are seeing the solution now. Solution you should divide always. Whenever solution is being asked for agriculture, you should always go for, like in soil conservation method also we have seen agronomical, mechanical, agroastrological, forestry, right? You should also remember these kind of formats. Automatically you should go for like for the solution part. Like here also we will go for the agronomical approach, that what we can improve in our agronomic practices in a dryland agriculture areas. You can go for important one, mechanical or physical solutions. Here you can also, for this particular dryland agriculture areas, you can also go for innovation or innovation in breeding, basically breeding aspects. Just wait guys, I'm really sorry. We were seeing solution for DLA, one agronomical, second mechanical, or you can say this engineering approaches or engineering solutions, or you can say physical solutions. Here you can write about or the innovation. For this specifically dryland agriculture, we can also go for innovation or breeding aspects. Now, first of all, dryland agriculture problems which you have seen is either I am getting too much of rainfall, either I am getting scanty rainfall. Automatically in your mind, two things will come, that we should go for soil water conservation and soil conservation. This much things are definitely you should go for, right? Now soil conservation, the things which you will like which will come, which you will write is those which we have studied in the last class only. Soil conservation methods in the form of agronomical, in the form of mechanical, but we are studying it under mechanical, so you know that soil can be conserved by contour bunding, graded bunding, gully uh, gully control, right? Like this, these soil can be conserved. You know that I also want water conservation. Now water conservation, which we are going to study it in further lectures, like the coming up lectures we are going to study water conservation in detail. So I'll telling you these particular heading which I'm writing, like water harvesting and other method like integrated watershed management, which will include these two both. Like we should go for these type of water conservation method, which we'll be studying in detail, don't worry. Basically we have to create earthen banks, bunds. This should all come under mechanical engineering, where we are constructing something, where we are creating something. Now if we can conserve soil, if we can conserve water, automatically my soil fertility will be good. My soil fertility will be good, then I'll be getting good economic profit out of the yield I'm getting. If I'm protecting water, then my soil, then also my soil fertility will be improved, right? I can give fertilizer to these areas. Fertilizer would be responsive to them. I hope you are understanding. When you are applying this mechanical, only this approach will not solve. Everything should be like together. We have to apply them. Like agronomical approach means now your soil fertility is improved. You are getting you are getting irrigation. You have stored water from these practices like water conservation and soil conservation. You have stored water. You can give them in the form of irrigation. So you can go for basically double cropping, and you can go for crop rotation. Agronomical, you have to save water, you have to save soil moisture. Mulching you should go for. Cover crops you should go for. Automatically those point, remember, of soil conservation, automatically they will come over here too. So utilize your information wherever you are studying, right guys? Here in dryland agriculture areas, innovation is needed in the breeding aspects. That means I have also told you that hybrid varieties or these type of varieties need high input. They are not meant for dry land agriculture areas. So here localized varieties should be developed, should be innovated for these particular areas only. Like this you can write. Also now, important thing which you have to understand is the case studies which you have to write and which will set you apart guys. Two case studies which you have to see is, or you have to, this is your homework. Hivre Bazaar case study of Maharashtra, where dryland agriculture is being converted, like dryland agriculture was being practiced. It is a low or drought prone area. Here through this watershed management approach. I'll tell you watershed management approach. Through the soil and water conservation approach, we have turned like this. Some people have turned this dryland agriculture into a very profitable business. Hivre Bazaar. Try to search it out. It will be your case studies, guys. Case studies you can also add from current affairs, daily current affairs. If you are reading the Hindu, the Indian Express, there, whatever you are seeing related to it, just try to note down. You should have at least 2 to 3 example, guys, not more than that. If you are investing more than that, you are wasting your time. Ultimately, you have to write answer in 250 words or 150 words. This should be your limit. You are not here doing PhD, you are not here becoming agriculturist, you are not becoming an expert, guys. You just want to go through this optional to, because you want the name in your in the merit. Just this should be your goal. So study very effectively. Whatever you are studying should be understood, should be stored in your mind. This is the major problem, that people are studying too much and they cannot store that much amount of information, and they cannot divulge that out in the examination time when there is only 7 to 8 minutes to write. Second one is a Sukho Majari in Haryana model. Automatically, this is also about dryland agriculture, how dryland agriculture farming is being converted into a agroforestry, a forest they have, like by implementing the soil and water conservation method. Try to read about this, you will like it. Also add some of the case studies. It this like dryland agriculture topic would be almost complete by you if you add this try like this case studies also. Also, I have added some of the like government initiative which are going on, like this you can see National Mission for Sustainable Agriculture. This you study under economy substand, like we will study also under we will also study these schemes, but not right now. Just try to understand that under these schemes the we have the provisions for these dryland agriculture. Not exactly, right? But you just see. The next important point which comes is contingency plan, guys. This you have to understand. Contingency plan. Contingency plan is like having a plan B. Or what if this fails, what will I do? Do I have a contingency plan? So for this also, we know that dryland agriculture area is basically dependent on rain. And we know that we are a monsoon country. So monsoon, because of this erratic monsoon, it is not sure that we will get rain on time when we need, when our crops need the water. So for that, do we have a plan? We will see it. Just wait. Now, there is one way to understand this contingency plan, guys, wholeheartedly. Just wait. Contingency plan, right? For these dryland areas, we have contingency. Suppose I am a farmer, I am growing again. I have 1 hectare of land. I am a farmer of a dryland agriculture area, DLA area. I have 1 hectare of land. I have decided to sow sorghum this year. Generally, now characteristics of this particular variety of sorghum is it will take 150 days to grow, right? 150 days to grow. I am growing that variety of sorghum. Now I am waiting for the water. As I am a dryland farmer, I am completely dependent upon rainfall. I am waiting. Generally, rainfall like monsoon, rainfall comes in the time of monsoon only, and in monsoon comes during June, right? Now I am waiting for the rainfall in June. The rain will come, and my crops will germinate, and the water required for my this particular variety of sorghum will be needed. Now, contingency plan I need when this thing is failing. That what if I am not getting the. Just wait, guys. Someone is calling. So I was telling you that I am waiting for the monsoon, but contingency plan. Do I have the contingency plan if the monsoon is arriving late? Do I have the contingency plan if the monsoon is going early or withdrawing early? So like I have three conditions basically. Under three conditions, one conditions can be that I am not getting the monsoon as I was planning for because of this erratic nature of monsoon. I am getting the rainfall late. So late arrival of monsoon is one condition. Second condition is early withdrawal of monsoon. Early withdrawal of monsoon means generally if monsoon goes away in October or September, it is going away 1 month, 2 weeks before. Third one is intermediate dry spell. What do I mean by intermediate dry spell? Means if monsoon has arrived on this particular date, but again the rainfall has stopped, the rainfall stopped for certain for like 7 days, 10 days, and this is the time when my crops needed water. Then what do I have? Do I have a plan? What will I do then? So these are the condition which we have to see. Under intermediate dry spell, we have to see a condition that the dry spell is coming at the time of germination. If that is coming on the time of germination, what will I do? At the time of vegetative stage, growth of vegetative stage, if this dry spell is coming, this second condition is coming under this particular head, intermediate dry spell. Third one is at a flowering stage and ripening stage. Because in these stages I need water, and if it is a dry spell or dry spell is coming, then what do I have? Do I have a contingency plan? Do I have a plan? And that plan is basically a contingency plan. All right, guys. So first of all, see three conditions. I am a farmer. I already told you I was growing sorghum. Sorghum variety takes 150 days. This variety. So late arrive. Now first condition we will see that suppose the monsoon is arriving late. Now how much late? Here also two conditions happen. How much late? If the monsoon is arriving only 1 week late, monsoon is late by 1 week only, then what will I do? My crop requirement, my days would be less than my cropping season is 150 days. This sorghum variety needed 150 days, but this 1 week is eaten by this late arrival. What will I do? Now here I will go for the different variety of sorghum. I'll go for the different variety of the crop which I was growing. Different variety of crop. You see the difference. Different variety of crop I would go for. For example, I would take that variety of sorghum now, which can be cultivated in or which can be harvested in 120 days. So I have saved this 1 week, which was eaten up by this late arrival of monsoon. Right, guys? Here I am not changing the crop. I am changing the variety of crop. So here innovation can come. Here solution we can find is that can we develop the same variety crops, the different variety of certain crops which should be of short duration, so that in the times of these when late arrival of monsoon we are getting or some hardships we are getting related to this rainfall, then we can go for these plan, contingency plan. Are we having these kind of crops with us? Here innovation can be done. Second condition can come that if monsoon is arriving greater than if on monsoon is late by greater than 4 weeks, that means 1 month. Monsoon is late by 1 month. What will you do then? You need 150 days to grow sorghum, but now here water or monsoon is coming 4 weeks late. That means the whole crop will be destroyed, the whole crop will die down because the availability of water is not here because of the late arrival of monsoon. So here I will completely change the crop. I'll go for some other crop, change the crop which I was growing. What I'll go for, I'll change the crop. Sorghum I was growing, now I will not go for sorghum. I will go for those crops whose growing season is small, like pearl millet, cowpea. Pearl millet growing season is around 70 to 80 days. Cowpea is like again 80, 70 to 80 days. Are you understanding? So those crops I would go for whose whose growing season is less, so that I can get something out of that land. If I plan to grow this sorghum only, then I'll get nothing out of it. But if I change it, if I follow my contingency plan, and according to contingency plan, I have late arrival of monsoon, one condition. Sub condition is I have 1 week late arrival of monsoon, then I'll go for different variety of that particular crop I was growing. If I'm getting monsoon by 1 month late or 4 weeks late, Then I'll change the crop and go for pearl millet and cowpea. Here these examples are important: pearl millet and cowpea. Now the second condition which you are seeing is early withdrawal of monsoon. Monsoon is withdrawing early. I need there is 150 days which I need for my this sorghum to grow, and monsoon the water requirement is at the end stage also, but monsoon is withdrawing early. So what will happen now? There will be rainfall constant, there will be water constant. So I have to conserve my available moisture in the land, right? So what will I go for? Anti-transparent spray, so that I can control the moisture which I have already got it with the presence of monsoon. I will control that moisture in the water only. How? Anti-transparent spray. Also, if I'll not go for any practices and I see that I know that this early withdrawal of monsoon has happened, and if I keep on growing that crop, then my sorghum will die down eventually, because the availability of water is not there because of this early withdrawal of monsoon. So this crop will give me nothing. So either I can harvest this crop early also in the form for fodder crop. I can utilize it for the fodder crop or for the animals, for the livestock, because it will something it will be having something like proteins or carbohydrate, it will be having something. But if it does not get some water, the whole crop will be destroyed. So I can utilize it by early harvesting of that crop in the form for this fodder crop. Now, third condition that comes is intermediate dry spell. An intermediate dry spell means there is no rainfall in between the periods which I need. For example, if I need water requirement for the crops is at the germination stage, what will you do? If the water requirement is at the vegetative stage and dry spell comes in at that point of time, what you will do? Flowering and ripening, what you will do? We will see it in a separate slide. Just wait. Intermediate dry spell condition we are seeing under contingency plan. This dry spell, if it is occurring at the stage of that germination, then two condition arise. For example, if I'm growing certain crop over here, and suppose I am growing 100 seeds, I have sown 100 seeds, and because of this intermediary dry spell, no water availability, only suppose 85 seeds are able to germinate, 15 seeds are not able to germinate. What do I mean by that is that less than 20% crop stand I have lost. Crop stand means these seedlings which are coming. Here you can see that 85 only came and 15 does not is not able to came. Then why it happens? Because because of this intermediary dry spell. So you can see one condition where less than 20% I have lost, only 15%, which is basically less than 20% crop stand I have lost, right? Second condition can come that what if only 70 seeds are able to germinate and 30 are not able to germinate, then I know that it is greater than 20%. So I'll say here greater than 20% crop stand is being lost. What will I do? What do I have? What plan do I have for this condition? So when I have this condition that only 20%, less than 20% of crop stand is lost, I'll go for resowing, or you can say not resowing, gap filling. Gap filling means these 15 seeds which are not able to germinate, I'll resow them. I'll fill the gap. If I have lost greater than 20%, then I'll resow the whole area. What if I am getting this dry spell at the vegetative stage? You understand this vegetative stage part? And what if here three things are important, like vegetative stage, flowering stage, and ripening stage? Water requirement is high at these stages, and if I'm getting intermediary dry spell, what will I do? Similar points, you will go for anti-transparent spray to protect the moisture of the water. You will go for fodder crops If you are seeing that water availability is not there and my crop will be dying if water will not be available, then I'll be utilizing these crops for fodder. So this two things you have to write for these stages, vegetative stage and for this particular period. See the framework which you have to understand. Now you can write everything: delayed onset, early withdrawal, intermediary dry spell, right? Again, I'll tell you the contingency plan for these like dryland farming areas. Contingency plan, you have three conditions. One, late arrival of monsoon. You understood this. You have know that late. I'm getting late monsoon arrival, and here's two sub condition can arrive. That is 1 week later, monsoon is coming, and monsoon is late by 4 weeks or 1 month. If 1 week late, I know that I'll go for some other variety of that particular crop. If 1 month late, I know that I'll change the variety or some, I'll change the crop. If I was going for sorghum, now I'll go for pearl millet or cowpea, which is of shorter duration. Second condition, you know that it is of early withdrawal of monsoon. Here you will go for anti-transparent spray fodder crop. Third condition, you know that intermediary dry spell. Here four condition can arrive. And one condition is at the time of germination, which is very important. Water is required at that time. Otherwise your seed will not be able to germinate. So if the germination, if the crop stand I am losing is less than 20% under this, like at the germination stage, if I am losing 20%, less than 20% of the crop stand, then I'll go for gap filling. If I am like losing the crop stand greater than 20%, I'll go for resowing. Also we can go for mulching to protect it, or these all factors can come like vegetative germination, vegetative flowering and ripening stage. You can go for anti-transparent spray, you can go for fodder crops, you can go for mulching, and all the soil conservation and water conservation practices can come. But this is the broad plan, contingency plan, which is needed to be followed. I hope you have understood this much. So let us do a quick recap, guys, what all we have understood till now. No matter how much you study, if you are not able to consolidate what you have studied, it will equivalent to zero. So as our practice is to just consolidate what all we have studied. So we studied about dryland agriculture and its constraints. This was a topic as mentioned in the syllabus. We are studying it under unit number 6, that is soil and water conservation. Under dryland agriculture, we tried to see the definition. Crop cultivation that is completely dependent on rainfall. Categories you understood on the basis of rainfall: 750 mm, what do we call? Less than 750 mm. 750 to 1150 mm, what do we call it? Greater than 1150 mm, what do we call it? Because this, if you remember, you can directly write it. Rest, dry farming, dryland farming, rainfed farming, everyone can remember. Here crops duration 75, less than 75 days. Crop failure is high. Here 75 to 120 days. Greater than 120 days of crops can be grown over here. Region, if you they'll talk about arid, semi-arid, humid regions. Example you can give by your geographical knowledge. Again, then you studied about the constraints for that, constraints of it, like what are all the constraints we have. Major constant, climatic. Automatically that climatic thing you will think about rainfall and temperature and monsoon, erratic monsoon. Rainfall you will automatically think about time and space. Under space, heavy rainfall and low rainfall. Under time, heavy, high duration, low duration, or long duration or short duration. This is the write down. Under temperature, if high temperature is there, ET losses are there, evapotranspiration losses are there. If erratic monsoon we are facing, then we have, for erratic monsoon we have three phases which we have seen in this contingency plan also: late arrival, early withdrawal, and intermediary dry spell. Under climate, after climate, one point, second point was soil. Under soil constraint, what you have seen was basically soil fertility, vertisoil, alphy soil, crusting problems, right? Organic matter problem. Just wait. Dry land agriculture definition, categories you have seen, right? Then you went for the constraints. This board is difficult to write, guys. Really sorry for the handwriting, but I'm just revising it, right? Constraints. You have seen climatological constraints. You have seen what? Soil constraints. You have seen traditional cultivation practices. You will write about the weed problems. You will write about the local varieties we should generate or the hybrid varieties which is being generated also. You can talk about the socio-economic conditions, and you will talk, you can connect it by showing a flowchart, a virtuous, sorry, vicious cycle you can show. Vicious cycle. Then after studying this, we went for solution part. I have told you you will write solution in the form of agronomical. Again, flowchart you can draw. Mechanical and innovation process you can say in breeding aspects. Everything is written in the slides. You can go from there also. After studying this whole, these much points which you will remember wholeheartedly, these sub points, we went for contingency plan. Contingency plan we divided into three conditions. Which are the three conditions? Late arrival, early withdrawal, and intermediary dry spell. Automatically, if intermediary dry spell, they will ask in detail. You write about the stages in germination, vegetative, uh, which one, flowering and ripening stage. Late arrival, they will ask you go for 1 week late or 4 week late. You know the difference now. So this much all we have covered in this particular lecture. The pace was, I want you to be with my pace, guys. I'm not teaching you too slow so that I will eat up your like 2 3 hours for this particular topic. The same amount of content is being taught in 2 3 hours, guys. I have tried to tell you, or I have tried to teach you this in one like more than like less than 2 hours, and you can utilize rest of the time by self revision. Try to find out those case studies which I have given you. Those case studies you can, this will supplement your this answers, guys, in the exam. This will fetch you more marks. So your homework was to see those case studies and try to revisit the lecture again, recall it. Okay, guys, thank you so much. I'll meet you in the next lecture where we will be studying water conservation methods and other topics of this particular unit. All right, guys, thank you so much. Take care.